Hello, good afternoon, everyone. Mr. JC here. So last week we finished chapter number 4, and for this week we are going to start chapter number 5. So I suggest you all to please watch this presentation very carefully because I'm going to upload a homework for you on this topic that we are going to study today. And as usual, we will have a quiz on Saturday on everything that I'm going to discuss here today. If you have any questions, you can always write me an email and I will try to get back to you as quick as I can. Also, just a reminder that this is the last week of marking period 5, so I suggest you all to please do your homework and do your last quiz on time because we will not have any makeup time for this thing. So in today's video, I'm going to give you an introduction to angle measures, special triangles and special angles. We will then talk about 5.1, and then I'm going to talk about the trigonometry of right triangles and the trigonometry and the coordinate planes. That's what we will be doing in today's video. So moving on. Okay, so here are three kinds of angles that we will be talking about. We have a 90 degrees angle, which we call a right angle. This is like this 90-degree angle. And then there are some angles which are less than 90-degree angles, like this one. And there are some angles which are more than 90-degree angles, as you can see here. So what I want you to remember is all the angles which are less than 90 degree are called acute angles. You can see it here. And all the angles which are more than 90 degrees like such, they are called the obtuse angles. And the 90-degree angle is also called the right triangle. Another thing that you need to know is you all have seen the clocks. Now the second arm of the clock, it moves in this direction. Therefore we call this direction clockwise direction. The opposite to this is anti-clockwise direction. So whenever I ask you or whenever I refer to a clockwise direction, it means I'm talking about this direction, and whenever I refer to counterclockwise or anti-clockwise direction, it's basically this kind of direction that we will be talking about. Moving on. Now before we do this question, I want you to know two more things. Always remember that when two angles, or more accurately the measurement of angle A and the measurement of angle B is equal to 90 degrees, we call A and B the complementary angles. So for example, if angle A is, let's say, 60 degrees, then the complement of angle A would be 30, because 30 plus 60 add up to 90. Similarly, can you try out this one? What if I have angle A as 45 degree? What will be the complement of angle A? Yes, you're right, it's 45, because 45 plus 45 is going to be 90. So these are called the complementary angles. The same way we can discuss the supplementary angles. The supplementary angles are those angles that, for example, when you measurement of angle A plus the measurement of angle B. So remember, for the complementary angles, these two angles added up to 90, but for the supplementary angles, these two angles should add up to 180. Which means if I have angle A as 130, for example, so the supplement of angle A will be 50, because these two add up to 180. The same way, if angle A is suppose 100, then the supplement of this angle would be 80, because these two need to add up to 180 once again. So I'm sure now it's clear about supplementary and complementary angles. Let's read this question. This question says, determine the measure of each angle described. So A part is the complement of a 57-degree angle. We know for the complementary angles, two angles add up to 90 degrees. So 57, you already have a 57 and you want to find the complement of this. So easiest way is 90 minus 57, that would be equal to 33 degrees, because remember, uh, 33 plus 57 add up to 90, and that's what we discussed. If we have angle 57, then what will be the complement of this angle? Of course 33, because these two add up to 90 degree. Look at angle B. The question B, it says the supplement of 132. So we all know that the supplement, two supplementary angles add up to 180. So if 132, we have this 132 degrees, what will be the supplement of this, so that both the angles add up to 180? So please try to find out this thing, and then I would like you to answer the part C of this question, which is about the right triangles. Moving on, and circle. Now you all know the circles. This is the first diagram that every child draws when they first learn how to hold a pencil. This black boundary here, this thing, is called the circumference of the circle. I'm sure you're all aware of this. This is the circumference. This blue part here, from the center to one point of the circle, is called the radius. And if you double the radius, like this one, that becomes the diameter. Two important things that you need to know. One is the area of circle, and the other thing is circumference of the circle. The area of the circle is pi r square, where r is the radius, and for the circumference you use the formula 2 pi r. Once again, r is the radius and pi is a value that you can find out from your calculator also, but it's 3.1815. So these are the things that I've already mentioned to you. Angles. We have already discussed these things. Quadrants. So this figure must be you must be familiar with this figure. This is the grid. These are the positive x-axis. This is the negative x-axis. This is the positive y-axis, and this is the negative y-axis. This is quadrant 1. Quadrant 1. Now notice one thing, in this quadrant, this whole thing is quadrant 1. Here the x values are all positive, the y values are all positive. When we talk about quadrant 2, this is the quadrant 2. Here the x values are all negative, but y values are still positive. In quadrant 3, as you can see, the x values are negative and the y values are negative. And in quadrant 4, as you can see, the x values are positive but the y values are negative. So these are 4 quadrants. You need to know these 4 quadrants because we're going to use them in our upcoming questions. We will now move on. Drawing angles. Now we have to draw these angles without using a protractor or any other devices. 45 degrees. Now, as you know, this angle here is 90 degrees angle because this is a right angle between y-axis and the x-axis. And we can easily find out that 45 is basically the half of 90 degrees. So this angle is 90 degrees, so half of it is 45. So if you want to draw this angle, before I start drawing the angles, just remember one more thing. If the given angle is positive, you will need to go counterclockwise. And if the given angle is a negative angle, then in that case you will go clockwise. So imagine this is a clock, and these are the two arms that you have on a clock. One is the minute arm, and the other one is the hour arm. This red one is the hour arm, and this one is the minute arm. So if I want to go counterclockwise, the red one shall go upwards. We discussed this, if you remember, a few slides back. And this red one, if I need to move to clockwise direction, then this red one goes down. All right, now 45 is a positive angle, and we know positive angles go counterclockwise. So this red line shall go counterclockwise, which is upwards, and this angle is going to be 45 degrees, because this is half of 90. Now from here to here it is 90, so half of 90 is going to be 45 degrees. Look at the second angle, minus 90 degrees. Now once again we have to start from here, this red line. The angle is negative. We know for negative angles we go clockwise, so this red line shall go down, and we know that this is here is the 90 degrees angle. So this is minus 90 degrees. I want you to try 225 and 405, and then you can let me know what your answers are. And if you have any questions about this, you can send me an email and I'll try to answer you for any of your doubts. We will now move on. There are three types of basic trigonometric ratios that everyone needs to know. One of them is the sine ratio, the other one is the cosine ratio, and the third one is the tangent ratio. But before we start, as I mentioned before, this is the right triangle, and I just want to briefly introduce this right triangle to you. As you can see, we have a 90 degrees angle here. That's why we call it a right triangle, because a 90-degree angle is called the right triangle. Always remember that the side which is opposite to the 90 degrees is called the hypotenuse. And hypotenuse are always the longest side of a right triangle. Then as you can see, this is the 90-degree angle, and we have two more angles. One angle is here, one angle is here. Sometimes this angle would be given to you, sometimes this angle would be given to you. In this case, in this triangle, we have this angle given to us. So whatever the angle given to us, either this one or this one, we call it reference angle. So in this triangle, this is the reference angle. So you need to remember that the side which is opposite to the reference angle is always opposite. And of course, the third side which is left, we call it adjacent. Now, I'm sure you already know all these three ratios: sine ratio, cosine ratio, and tangent ratio, but just to give you a very quick recap. Always remember, if we have a right triangle like so, like this one, then the sine theta will be equal to opposite divided by hypotenuse. I tried to color these two sides so that you can clearly see what's happening here. So the sine is opposite over hypotenuse. For the cosine ratio, once again, our reference angle is given, and you know what the hypotenuse is. So the cosine ratio will be the adjacent divided by hypotenuse. For the tangent ratio, we have opposite divided by the adjacent. You can pause the video anytime and you can just have a look at all these three trigonometric ratios once again. So this is what we discussed, that the sine ratio is opposite over hypotenuse, the cosine is adjacent over hypotenuse, the tangent is opposite over adjacent. You have to make sure that the triangle is a right angled triangle, because in other triangles you do not have the hypotenuse or the adjacent side or the opposite side. We have already discussed the acute angles, obtuse angles, the right triangles, the complementary angles, and the supplementary angles. Look at this question. This question says find all the 6 trigonometric ratios by using this triangle. Now we do not know which one is the reference angle, because reference angle is not given to us, but we have a right triangle. If in a right triangle 2 sides are given to us, we can find out the third side by using a theorem called Pythagorean theorem. In Arabic, it's called, if I'm not wrong, it's called Masala Pythagoras. Now, for many of you, I think it should be clear that what I'm talking about. The Pythagorean theorem, according to the Pythagorean theorem, the hypotenuse square should be equal to opposite square plus the adjacent square. As you can see, we have hypotenuse given. I don't know which side is opposite. Either this one can be opposite or this one can be opposite, but for hypotenuse we are sure that this is the hypotenuse, so we will use this 5 as hypotenuse. So let's plug in the values here. 5 square equals to opposite, let's say, I don't know what opposite is, so I'll just keep it as opposite square, and the adjacent is 3 square. So 25 equals to, alright, so this is 25, and then this is equal to opposite square plus 9, and now we know we need to move that 9 on the other side. So 25 minus 9 equals to opposite square. This is 16 equals to opposite square. That gives us opposite to be 4. Now once again, please do not confuse yourself. Opposite, when you take the square root of both sides, the answer for opposite cannot be plus and minus, because the length cannot be negative. So opposite is 4 here. This is the question okay, I will solve this question for you very quickly. So once again, here, as you can see, we have an angle given to us, a side given to us. We need to find out the other 2 sides and an angle here. Now it's easy. As you can see, this is a right triangle. If this angle is 40 degrees, then this angle has to be 90 degrees. I'm sure you all know this, but just to give you a quick recap, always remember that the sum of all 3 angles of a triangle is always 180 degrees. So in this case, if angle A is 40 degrees, B is unknown, and C is 90 degrees, then we can easily find out the value of B by adding these 2 things up. That would be 130 degrees plus B square, B equals to 180 degrees, which means B angle is going to be 180 minus 130, which is 50 degrees. So this angle is 50 degrees. Now, since you have all the 3 angles given to you, and if you want to find out the sides A, B, and C, that should be easy, because we can use one of the trigonometric ratios to find out these sides. For example, for this particular case, I'm going to take B as my reference angle. So if B is my reference angle, then this side is going to be opposite. So my opposite here is 2, and my reference angle is 50 degrees. Let's say I want to find out C, which is, in this case, is hypotenuse. So now think about all the 3 trigonometric ratios that I told you about. Which trigonometric ratio involves opposite and hypotenuse? That is sine. So sine of 50 degrees should be equal to opposite over hypotenuse. In this case, you need to do the cross multiplication, and which will result in hypotenuse equals to 2 over sine 50 degrees, and you can use your calculator to find out the answer for this. Once you find out the value of c, then either you can use one of the trigonometric ratios like sine, cos or tan to find out a, or you can simply use Pythagorean theorem to find out the third side. Please find out the third side and share your answers with me, and if you have any questions, I'll be very happy to answer. This is a very similar question that we just solved, and I want you to answer this question by yourself. Let's solve some application questions. This question says two equal height minarets are 200 feet apart. Both make a 90-degree angle with the ground. If a rope of 520 feet is tied to the top of one minaret to the bottom of the other, what is the length of the minaret? Let me draw these two minarets. Here we have two minarets here. Let's say this thing and this thing. These two minarets are 200 feet apart and both make a 90-degree angle with the ground. A rope of 520 feet is tied from top of one to the bottom of other. So this is 520 feet. We need to find out the length of the minaret. This is what we need to find out. Now, as you can see, that's again very easy. You have it looks like a right triangle to me, with a hypotenuse of 520 and adjacent of 200 feet. We need to find out the opposite side, and we can once again use Pythagorean theorem to find out the opposite. It's doable. I think you can do it by yourself. I will leave it as an exercise for you. If you have any question, please get back to me so that I can answer those questions for you. One last question is this one. One of the largest cinema screens in the world is at Pictorium Theater in Santa Clara, California. The rectangular screen is 70 feet by 96 feet. So which means the height is 70 feet. The height of this cinema screen is 70 feet and the width is 96 feet. What is the diagonal measure of the screen? So this red line that you see here that I've already drawn for you is a diagonal measure. You already have two sides given to you. You have to find out the third side. You know what to do. I'm not going to tell you which method you can use here because I want you to find out which method can be used. We have already discussed it in this video. And right. The next part that we have to do is how we can convert from degrees to radian and from radian to degrees. The radian measures are always in pi's, and the degree measures are always in 180s. If you look at your calculator, you can convert your calculator either into degree measures or in radian measures. The next topic that we are going to discuss will use the degree and radian measures. So it's very important for you to know how to convert from the degree measures to the radian measures and from the radians to degrees. These are the two formulas that we will be using to convert from degree to radian and from radian to degree. Look at this blue one. 1 degree equals to pi over 180 radians. So for example, if I give you an angle in degrees, for example in this case if I say convert 90 degrees into radians, so all you need to do is multiply this 90 with pi over 180 and simplify this using your calculator, which will be pi over 2. So your 90 degree angle is now converted into radians, which is pi over 2. Similarly, if you have anything in radian, for example pi over 3, and I want you to convert this into degrees, all you need to do is multiply it with the reciprocal of this, which is 180 divided by pi. Now pi cancels out with pi, and 180 divided by 3 gives you 60 degrees. So which means the pi over 3 radian is actually 60 degrees, and 90 degrees is actually equal to pi over 2. Once again, please try to convert more angles from degree to radian and radian to degrees, and if you have any questions, I'll be very happy to answer those questions by email. Moving on, I will leave these questions for you. Please try them and let me know if you have any more questions. Arc length. So we are talking about a circle here. Imagine it's a pizza, and I'm sure like me you all like the stuffed crust pizzas. The stuffed crust pizzas are those in which this part of the pizza is filled with cheese. So for now, I'm only talking about this part which is filled with the cheese, not the whole pizza pie, okay? This whole thing. I'm not talking about this thing. I'm only talking about this part here which is filled with the cheese. This part of the circumference of the circle is called the arc. And the formula to find out the arc length is S equals to r theta, where S is the arc length, r is the radius, and theta is the angle here, theta. There's one thing that is very important for you to know. Whenever you want to find out the arc length, the angle here, angle must be in radians. So if the given angle is in degrees, you will first have to convert it into radian and then plug that in this formula. Now, for example, in this question, all right, I'll solve this question for you, that's fine. If a circle in a figure has a radius 10 degrees, what is the length of the arc subtended by an angle 3.5 radian? As you can see, the angle is already in radian. So all I need to do is S equals to r theta. We know the S is 10 and the theta is 3.5, and so the arc length is going to be 35 centimeter. So that's it. That's what you need to do. Moving on. As we found out the arc length, we can find out the area of the sector. Once again, look at this circle. This blue line here, the part of circumference, we called it arc. But now we are talking about this whole thing, like the pizza pie. This pizza pie is called the sector. To find out the area of the sector, you can use the formula half r square theta. So once again, theta is the angle here. Okay, this angle is going to be theta. So again, you have to remember that theta must be in radian. So if the given in a question, the given angle is in degrees, first you need to convert this into radian, and only then you can apply in this formula. I'll see if I can answer some questions for you, if I can give you an examples. Otherwise, it's a very simple formula. I'm sure you can all try it at home, and if you have any questions, you can always ask me. Right, look at this question. Find the area of the sector of a circle with radius 2 feet formed by an angle 30 degrees. So as you can see, the angle given to me is in degrees. So first I need to convert this 30 degrees into radians. So to do that, 30 times pi over 180. And if you solve this thing using your calculator, your answer is going to be pi over 6. So 30 degrees is basically equal to pi over 6 radian. We are now ready to use this angle in the formula of the sector. The formula of sector is half r square theta. As you can see, the angle, the radius here is 2 feet. So 2 square pi over 6. That would give you, if you use your calculator, it's going to give you 2 times pi over 6, which is equal to pi over 3. So this is the area of the sector of the given circle. So these are the questions that I want you to try at home, and if you have any questions, please you can contact me through an email. That's it for now. So whatever we have discussed at the moment, these all things will be included in your Saturday's quiz, and homework is on my MATLAB. I wish you all the best and see you soon. Thank you.